Okay, so now the next topic I want to show is the node management. This is mainly for the operations people, almost always. It's not for developers. And what I want to show you here in the node management is that if in Lens tool, if you click here, this shows about the node details. What is internal IP, external IP, and the operating system kernel version and the kubelet version. It shows the basic details. Okay. And if you were to configure it with Prometheus or some other monitoring tool or information gathering tool, it will show you in a graphical way here. But we are not set up. And this guy says, okay, this is a 2 CPU machine, 4 GB, and around 10 GB of storage, more details. And it shows what parts are running on this Linux operating system. Because whatever Kubernetes is, whatever Docker container is, whatever pod is, whatever services is, whatever networking is, the only reality is a Linux kernel. All of these things are running only on Linux kernel. If there's no Linux kernel, there's no Kubernetes, there's no Docker, there's no pod, there's no nothing. Okay. The reality is Kubernetes and the whole application is running on Linux operating systems. Okay. So there are 4 operating systems node, and the master nodes are managed by Google Cloud because it is GKE. Otherwise, we ourselves would have been managing it. Okay. So now on the node 1, these are all the parts running. Okay, as you see, there are so many parts running. Our Flask pod, some metric server, Fluent bit for logging purposes, right? And metrics gathering, all these other parts, whether by default, it is all running, right? So there's a Rajesh pod with this name, and in Sachin namespace, there is this Nginx with in it Sachin pod is running. Okay, now, and so that is a node 1, and this is node 2. Okay, and this is from pool 1, and this is from another pool. Okay, so this is also a 2 CPU, 4 GB machine with 10 GB, and there is some problem. Wow, interesting. So there's no pod on this machine. Lesson learned. Nothing is running for what, yeah, on that machine. And this guy, there's 5 running. Really? Nothing is running? Oh, sorry, my mistake. There are 6 parts running here. Nginx deployment part is running from ASCII namespace, and this guy, whatever these parts are running. Okay. Now, what I want to show is now um, Kubernetes has no single point of failure, right? Now, these parts are running here. What will happen to any of these parts if I want to take some sort of maintenance activity on the Linux operating system, which is underneath all of these Kubernetes and pods and containers and Docker and stuff, right? I want to take maintenance. I want to reboot the operating system for whatever reason, or even somebody pulls the power cable out of this Linux operating system. Then the promise of Kubernetes is that whatever pod running on any of this machine, the scheduler will see, okay, I'm supposed to have this number of pods. Okay, let us say this Nginx deployment itself we had, right? Okay, let us go back and look at this part. The Nginx, sorry, our Flask deployment, which has got a 10, right? So this guy is running on, where is the host name? Node, this node, okay? Cluster 1 default pool. And this guy is running on cluster 1 default pool 1. And this guy is running on cluster 1 default pool, cluster 1 default pool, cluster 1 default pool, but F1, I think this is a different, or is the same default. Okay, what are the node names? Or we could even look at from the node point of view. Default pool has got many Flask deployment, and the second node of the default pool also has got few Flask, like one Flask deployment. Let us increase more. because I have more capability. I mean, sorry, more CPU memory disk looks like. I'm adding 10 more because I want to load this environment, because I want to have more pods running here. See, you see all these new guys came in here, the Flask deployment. So I have a deployment of size 20 because I increased now. It came in distributed load on these guys. And on these guys, uh, it did not add much because maybe the scheduler decided, okay, I have space on those two nodes. Why should I add this unnecessarily? Okay. So all these parts are up and running. Now, this is node number 2, where I have 2, 4, 6, 8 pods running. Now, I want to take maintenance on this pod. Okay. So okay, now before that, let us ensure that we have 20 pods. Kubectl get deployment. Is it Flask deployment? Right? You see 20 parts up and running. Obviously, that's what we decided. Now, let us go to this node, the second node, where some of these guys are running. Now, there is a command called drain. Before I want to take maintenance, I can click drain, or I can cordon. See, cordoning means, like as you see in a police scene, people cordon off with that yellow color like tape. That means that don't bring any more new parts onto this node. Okay, so I can cordon. Means I'm telling Kubernetes, hey, look, don't bring any more new parts onto this machine. So it means scheduling is disabled on this Linux operating system node, right? So no more new scheduling, but the existing guys are going to run as it is. The existing guys will stay as it is, no problem. But if you want to scale down and all, things will change. Now, the next thing I can do is I can do this thing called drain the node, because I don't want any part to be running because I'm going to restart or whatever of this operating system. I can click here uh, and it will drain the node. So drain means evicting. See, evicting pod. So it means that Kubernetes cluster, when I say, hey, I'm going to drain this node, it will evict all the pods on this operating system and it will throw in other nodes. It will restart them in the other nodes and then say, okay, look, it will start it another node and delete it here and say, okay, eviction complete. Okay. So now if you come back and see, because I have evicted, all these guys are terminating here, right? It will terminate one by one. It will create another node and then terminate here. And these daemon sets, which are expected to run, will always be running. And then if you restart the operating system, no problem. It will be it will just die because these are daemon sets which are supposed to be running. So right. So I cordoned off this node and I drained this node. So what Kubernetes will do is it knows, okay, now all the pods has to die here or has to be removed. It will go to the other nodes and start all those pods and put them into services, do the networking, do the health checks. And when it is healthy, it will delete those containers from here or the pods from here. And none of the application related pods are here now. Now I can delete this pod or I can restart this operating system. Right now, if you see, all these guys will have more parts here. If you see here, see, there is more parts than as you saw earlier. Now I logged into this operating system. Okay, ls uptime, it was up from 6 days because I think that's when we set up this thing. Now I'm going to reboot this operating system. Okay, now the operating system will reboot because I'm maintaining, upgrading, or doing whatever I want to do. And then when the operating system comes back up, I'm going to say, it'll take few seconds. Then I will say, uncordon. Uncordon means it is back into business. Like, send the load. When I click this, it is uncordoned and it is ready. Now, any new load comes, it will send here. Okay, now let us scale up. Okay, let us go to our second guy. Oh, it says it's not ready. Why? I've uncordoned. It will take some more time to get ready and add it to this. I don't want to train. I don't want to cordon. Yeah, it will take for the Linux operating system to come back. But the point is, the user will not know any of these things because when let us go back to our image here. As you saw, this guy changes here, right? So let us say you are not doing anything. This is not the services and all. Let us assume these three guys were sitting on this operating system. Operating Linux kernel 1, and then this is another operating system on which these two guys were sitting. So now when I say this node drain, which is actually a kubectl node drain command, because Kubernetes knows that, okay, there are like other operating systems in this environment. Say, let's assume I had only three pods on two nodes, right? So this is node 2. Now, when I say drain this guy, then he will go and add pods in other healthy nodes, and then it will delete these guys so that this node is empty for me to reboot or take for maintenance. Okay, so this is how you this is like, removing the rug under the chair for somebody to sit. So you can just say node drain, and then it will evict those parts. And see, now this guy is ready. Did it put more load here? Not yet, because it's not needed, because actually there is no load here, right? If I create few more, some of them based on the intelligence and the logic of this guy, of the scheduler, it will place here, it may not place there, but then it is the job of the scheduler to do that. Wow, even now it is not. So we should add some load. That's the point. Did it add more machines here? Not yet. Not yet. Yeah, so looks like, wow, all 30 of these guys are here only. And why is this container creating and waiting? Okay, let us see if we can break this system here. I thought it shows the host name. Oh, okay. Oh, see here it shows the host name, but then this is not like broad enough for us to see, I think. Because actually it shows the host name here. See, this guy is F1C, and this guy is also F1C. Let us look at the bottom and see. This guy is the other pod you see here, right? So this is the job of the scheduler to schedule it at the right place. This is the first guy. And then if you see here, that pool 1, it was not scheduling earlier. Oh, still it is not. Okay, see, now it is scheduling on this pool 1's second machine. So it intelligently distributes. It knows nobody is sending any load here, right? See, for example, if you do lots of curl is still running, only one curl, right? So it's like as the one user using. But if more user was to be using, like if you guys also want to run curl in parallel, right? So I can do like multiple curls from multiple tabs is quick and dirty way to generate the load is this. I can have like 10 tabs and generate the load. Okay, so this guy's got this application running here, and it's not sending load here because maybe this Kubernetes believes these two nodes has got sufficient space, so it is running here all these parts, right? So this is one advantage where when you write an application, whether 20 users are using or 20 million users are using, Kubernetes will take care of scaling part, right? So because we don't know, like some application there's only like few people will be using, or some application will be like a wildfire. People want to use, like millions of people across the globe want to use your application. Then Kubernetes will take care of all those scalability, and then it'll not even waste our money because uh, it'll only if it wants more nodes, then you can have cluster autoscaler. But otherwise, intelligently, there is this thing called horizontal pod autoscaler. It should be part of one of these configurations, I think. See, HPA. In HPA, you can create a configuration saying that add a pod if the CPU or memory is more than 80% used, and delete a pod if the memory and CPU goes then 60% used. So whether it has to run 3 pod or 300 pods, it will decide based on how much requests are coming and how much CPU and memory is used. How awesome is that? This is an inbuilt capability of Kubernetes. I've not set it up yet, but almost always by default, we can set up a horizontal pod. We need to set up a horizontal pod autoscaler. Uh, okay, task, walkthrough, either of these things we can go, right? So by default, when you do any deployment, you will set up a horizontal pod autoscaler where you are going to say, it's like trivially easy, like only 10 lines, like a horizontal pod autoscaler. No, wait, where is the full configuration? Yeah, see, you can have any of these horizontal pod autoscaler configurations where um, I just want to show, yeah, see, the CPU of this application, if the utilization is above average utilization is 60, then it has to maintain that, right? So if it is above, and you can also have, say, like, it is above 80% add a pod, below 60% delete a pod, right? So between those two levels only, it will keep, and it also can say like how many seconds you have to keep. Like suddenly if the load decreases, it should not delete all the unnecessary part because suddenly the load might increase. So you should have few spare pods running. So horizontal pod autoscaler will take care of that configuration. You see now, for the sake of purpose of demo, I'm actually setting up how many pods, right? I'm saying what is the scale, whether scale is 100, replicas is 100 or 10. I'm configuring it now here manually. But in a real Kubernetes cluster, I'll go an extra mile. I'm going to configure a horizontal pod autoscaler, just 10 lines. And I'm going to say, like, this is the percentage, only stay between this percentage. So whether 20 users are coming or 2 million users are coming, we need not wake up and scale down. Kubernetes will take care of that. Okay. that is about some of these node operations I want to do. Developers need not do it because the operation team would have said, okay, see, that is what we spoke is horizontal pod autoscaler for the number of pods. But now, how many nodes should be there? So that also in GKE, as you might have seen, we can say, okay, have 2 nodes to 50 nodes. So it will have 2 nodes initially. If the load increases, it will add a node and it will add pods. And then load increases, add a node, add pods. Add a node, add pods. It'll keep on going. But then when the load decreases, it will wait for 1 minute and say, okay, now there's less load. Remove all pods, evict all pods, and then delete the node. Evict pods, delete the node. That scheduler will work hand in hand with this horizontal pod autoscaler and the cluster node autoscaler. And then the whole cluster or the number of nodes, everything will scale up and scale down with near zero effort from the operations people or also the developer. Developers can sleep soundly at night, and operation people also need not worry when they set up all these things on day one. That is all I want to cover for today. Any questions? If there are no questions, I will stop recording.